Hey class, today we're going to put our stoichiometry knowledge to the test by looking at a limiting reagent problem, or limiting reactant as it's sometimes called. The question says, what's the greatest amount of NH3 in grams that can be made with 4.7 moles of N2 and 6.3 moles of H2? What is the limiting reagent? Which reactant is in excess? And then how many moles of that excess reagent are left? Okay, so there's kind of a couple of things we're going to be looking for in this particular problem. First up, that equation is not balanced. This is a simple ammonia reaction, and we've probably seen this before. To balance it, we need to make nitrogen, 2 here, 2 here. That gives us 6 hydrogen. Diatomic hydrogen can form 6 by simply putting a 3 in front. And for a place marker, we're going to put that 1 in front of nitrogen. That'll help us when we get to the mole ratio. Now, we want to find out which one of these reactants is the limiting reactant. Which one keeps us from producing more product? It limits how much we can produce. So to do that, we're going to look at the mole-to-mole ratio for both hydrogen and nitrogen as compared to what our problem gives us. All right, let's look at nitrogen first. 4.7 moles of nitrogen is question mark moles of H2. When our mole-to-mole ratio of nitrogen to hydrogen is going to be 1 to 3. So 1 mole nitrogen for every 3 moles hydrogen. Now we're just doing a mole-to-mole conversion. Cross multiply. .7 times 3 is 14.1. 14.1 divided by 1 is 14.1. So in order to use up all of this nitrogen, we'd have to have 14.1 moles of hydrogen. Okay, some of you may be looking at this and realizing what's going on, but just in case, let's do both sides. So 4.7 moles of N2 as compared to 6.3 moles of H2 over question mark moles of N2. This time we're just going to flip those. The hydrogen-nitrogen ratio is 3 to 1. So 3 moles hydrogen for every 1 mole nitrogen. Now cross multiply. 6.3 times 1 is 6.3. 6.3 divided by 3 gives us 2.1 moles of nitrogen. So for the amount of hydrogen the problem gives us, 6.3 moles, we need 2.1 moles of nitrogen to be able to use this all up. Do we have that? 2.1? We got plenty. 4.7 is how much they give us. So based upon this, if we need 14.1 moles to use up all of our nitrogen, we don't have that in hydrogen. So in this case, hydrogen is our limiting reactant. And on the flip side, nitrogen is our excess reactant. Okay, now let's figure out the other two questions, in this problem. First up, it wants to know the greatest amount of NH3 that can be made in grams based upon this scenario. Well, if we're looking at the greatest amount that can be produced, we're not going to look at the excess reagents amount. We have to look at the limiting reagents amount because it's going to prevent us from producing any more product. We set up another mole to mole conversion. Take our hydrogen because it's limiting, 6.3 moles of hydrogen for every question mark moles of NH3. And then look at our mole to mole ratio from hydrogen to NH3 or ammonia, 3 to 2. So 3 moles hydrogen for every 2 moles NH3. Cross multiply, divide. 6.3 times 2 is 12.6. 12.6 divided by 3 is 4.2 moles of NH3. Is that what it asked for though? It wants grams. Now we got to do a mole to gram conversion, which is the first thing we learned in this unit. But in order to do that, we have to have our molar mass. So let's set this up. Nitrogen, we just have 1, so 1 nitrogen is 14.007 grams. And we have 3 hydrogens, so 3 hydrogen. Hydrogen's 1.008. So 3.024. Add that together, we get 17.031 grams per mole. Now, plug this in like we know how to do. 4.2 moles of NH3. Railroad track, railroad tie over 1. We want moles to go away because we want grams, so moles is going to go on the bottom. So 1 mole of NH3 is equal to 17.031 grams of NH3. Cancel out your units. Bottom part, 1 times 1. Don't even have to worry about that. We end up with 4.2 times 17.031. 71.5302. Our problem gave us 2 different numbers with 1 decimal point. So we're going to round to 1 decimal point. In this case, it's not going to do anything. 71.5 grams of NH3. Now, the last part, we already know which one is in excess. Nitrogen is our excess. How many moles of nitrogen are left over? So how many moles of nitrogen are unused? Well, we looked at it up here with hydrogen. Let's see, right here. This part, with 6.3 moles of hydrogen, which is going to be our limiting reagent, we would need 2.1 moles of nitrogen to completely use up all that hydrogen. So we've got plenty, we said earlier. So 4.7 moles is how many we have. we're only going to use 2.1. So just a simple subtraction problem. 4.7 minus 2.1, we're going to have 2.6 moles of nitrogen left over. That pretty much encompasses any type of question you can ask on a limiting reagent problem. A lot of times it'll just say, what's the limiting reagent? But I figured for the demonstration, let's put all of this knowledge together. And again, none of this is new. This is all just stuff we've been doing, but looking at it a different way.